So you are welcome to WAEC chemistry preparation, and this video will help us in our upcoming exam that will take place next week Tuesday. It's on chemistry practical. So I just quickly want to explain some of the things in the first part, which is the quantitative analysis. You know that your WAEC chemistry practical is 50 mark, and you have theory section. We are going to titrate, that's quantitative analysis. Then we have the qualitative analysis, and then we have general knowledge on chemistry practical. That one usually takes around 10 marks or 8 marks, but the one that usually carry a lot of mark is quantitative analysis, which is your titration. So out of the 50 marks, it usually carry around 20 to 20 theory. So it means that if you are able to do this very well, it will help you for your chemistry. At least it will boost your score very well. So know that we are the specimen provided. We are asked to provide HCl, hydrochloric acid, and sodium hydrogen triacylcarbonate 4. That's NaHCO theory. So now look at the question very well. Look at the question. So the put solution A in burette and titrate with 20 cm cube or 25 cm cube of solution B using methyl orange as indicator. Now let me quickly go. Now let's look at the equation of the reaction. The equation of the reaction is already on the board. That's HCl plus NaHCO3 will give us NaCl plus H2O plus CO2. And this equation is already balanced. It's already balanced already. And we can see something there. It's one of the general properties of acid. When acid reacts with triacylcarbonate 4 or hydrogen triacylcarbonate 4, CO2 is given off. So you can see in that equation the CO2 that is given on. And you actually don't need to balance this equation because it's already balanced. Now, the volume of pipette use, and let me quickly chip in something. Before you draw your table, you must put the volume of your pipette use and indicator before you start drawing your table. If you do not do that, you will lose some precious mark. So the volume of pipette use, it depends on your school. It can either be 20 or 25 cm3, but most time or most school that I know, they are using 25 cm3. So you put the volume of your pipette use there, and also you indicate the indicator that you use, either methyl orange or phenolphthalein. Most time methyl orange or phenolphthalein, but here I'm using methyl orange. Now let's look at my table for titration. Just look at it first. If you look at a table very well, you will notice something, that all my values, all my readings are in the same decimal place. That is 2 decimal place throughout. So please, I'm begging you, when you are doing your exam on Tuesday, your table, it must be in 2 decimal places throughout. 2 decimal place through. Even if just 0, don't just write 0, you have to write 0.00. And look at it. I have final burette reading, initial burette reading, and volume of acid use, and there is unit there. You must put your unit there. And in this case, I carry out my rough titration, then the first, second, and third titration. You can decide to do 2. You can decide to do 2. But I'm just doing theory. You can decide to do 2. Maybe if they are rushing on that Tuesday, or your school does not have enough solution like that, you can just do 2. Now let's look at the volume of acid use or the titer value. I just took average of the first, second, and third titration. And let me teach something. For you to take average like that, your value must be concordant. The meaning of concordant is that they must be within the range of 0.2. So that's why when you are doing your work on Tuesday, make sure that the volume of your acid use, they are within the range of 0.2 cm3. They are within that range. So you can see my value here. The first one is 24.10, the second one is 24.10, and then the third one is 24.20. So you can notice that they are within the same range. So your work must be within the same range. And sometimes you can even do 3, but it is only 2 that you will take average of. If those 2 are concordant, that means they are between their difference is plus or minus 0.2. So please don't forget that fact. And this volume of acid use, you can ask your teacher. You can ask your teacher about the titer value, the volume of acid use for your own school. This value here is not for general. Let me say it again. It is not general. Do not use this one. Ask your chemistry teacher. It is the value of your own school, and then you walk around those values, because it's very important. And WAEC, during your WAEC exam on Tuesday, your teacher will be given a report form, and in that report form, your teacher will have to write out the school titer value, and your work must be within that range. In fact, most especially plus or minus 0.1 or plus or minus 0.15 of that range. Because if it is not if it's outside that range, you begin to lose some precious mark. So this is the equation of the reaction, and this is my table. Now let's look at the first thing that they ask us to find. That's the concentration of solution A in mole per dmq. So this is the concentration of A in mole per dmq. Okay, of solution A in mole per dmq. The first thing that I did is to calculate the mass concentration. And mass concentration is mass over volume. And if you notice in that question, the volume is in cm3. So I have to convert to dmq. And how do we convert to dmq? Just divide that cm3, divide it by 1000. So my volume is actually 0.5 dmq. And the mass is 4.15. So 4.15 divided by 0.5 will give us 8.30 gram per dmq. So that's the mass concentration, or the concentration in gram per dmq. But the answer is not what we are looking for. We are looking for the concentration in mole per dmq, or molarity. You can call it concentration in mole per dmq molarity or molar concentration, depending. It's still the same thing. So it is mass concentration over molar mass. And what's the molar mass of HCl? I've done that calculation. It is 36.5 gram per mole. And you must put your unit there. Unit is very important. So the concentration will now be mass concentration over molar mass, which is 8.3 over 36.5. And the answer is 0.227 mole per dmq. And when you are working in mole per dmq, your answer must be in at least 3 significant figure. It must be in 3 significant figure. If I just write 0.2, you will lose mark. If you just write 0.2, you will lose mark. If you just write 0.23, you will lose mark. It must be in 3 significant figure. Now let's look at the question 2. That's concentration of solution B in mole per dmq. So we use the formula that we all know very well. That is CAVA over CBVB is equal to NA over MB. The Ca is the concentration of your acid in mole per dmq. The Va is your titer value, or the volume of acid used. The Cb is the concentration of your base or salt. And then the Vb is the volume of your pipette. Na and Mb are the mole ratio. And from that equation, they are 1:1. So we are looking for concentration of solution B. So if I now make Cb the sort of formula, it will be CAVAMB over NAVB. So, and the answer is 0.219 mole per dmq. Now the third question, and don't forget too, for my CB, the answer is also in 3 significant figure. Don't forget, your answer must be in 3 significant figure. Now look at the Roman figure 3. We have to calculate the concentration of solution B in gram per dmq. When we are talking about concentration of gram per dmq, it's also the same thing as mass concentration. And mass concentration is concentration in mole per dmq times molar mass. And the molar mass of Na is CO3. I've done it already, you can see it there. So you can use it to find the concentration in gram per dmq. So that will be, and the concentration in mole per dmq, that's our CB. We've gotten it in question 2. So we just slot it times our molar mass. And then the fourth one, we have to calculate the volume of CO2 that will be evolved at STP if 500 cm³ of solution B is completely neutralized by solution A. So now look at what I did. We should know this formula, that mole is equal to concentration in mole per dmq times volume. So look at that Roman figure 4 is on your screen. Roman figure 4. Concentration, number of mole is equal to concentration in mole per dmq times volume. So, and I have to convert my 500 cm³, I have to convert it to dmq. So I got my mole. And now, so look at how I did the calculation to get the volume. So just look at it. So I wish you the best of luck. Have a wonderful time. Goodbye.